Hello, good afternoon. Today we are in the lecture 10 of Unit 1, Introduction to the Fluid Mechanics. In the last class we have discussed about measurement of pressures, how to calculate the pressure at a point in a fluid container based upon some mechanical and other devices. So in those devices, basically we are measuring in the two types of measurement devices. The first one is manometer type of devices. The second category is mechanical gauges or pressure gauges. So we are having manometers is one device. So the second device is mechanical gauges or pressure gauges. So in the manometers, we are taking a reference of a glass tube where the liquid is flowing in the glass tube. Based upon the level of the water or fluid, which is the same fluid or of different fluid in the manometer, by seeing the pressure difference, we can check the pressure in any container, which is an open container or closed container. Whereas in the pressure gauges, mechanical or pressure gauges, we are using some mechanical components like dial, a spring, a needle, and a pointer. So by making use of those mechanical devices, by making a linkages between them, among them, we are getting the readings on the dial gauge. So like this. For measurement of the pressure, we are using two methods of devices. One is manometric devices, other one is manometric devices, other one is pressure gauging devices. Now, today in this class, we will discuss about U-tube manometer, micromanometer, and differential manometers. Based upon that, we are having the problems. Now we'll start the topic. So in the last class, I have mentioned the categories. There are two types, manometers and mechanical pressure gauges. Now you already got some awareness about this classification. Now get into the actual process. So in the last class, we have mentioned about the formulas, what we are using for this manometer. That is, the value of PA is given, that is atmospheric pressure plus gamma into H. So whenever the container, if the container is not open case, so we have two examples. One is the container is in closed condition, other one is the container is in the open condition. So in both cases, we have took the concept, right? Here we took the pointer A, the point A, where it is the container, which is open in this case. If it is open in this case, this is the formula what we are using. If it is not open, if it is closed, we are using this formula. So like this we have discussed in the last class, right? Now, if there is the specific weight of water in the container, then we get the formula HA is equals to H atmosphere plus specific weight plus height is equals to 10.3 plus SH. These are used for hydrostatic pressure head equations, right? Next. Now see the difference, the U-tube difference. So here it is, the liquid is inside the container, right? So this is a manometric fluid. Now if you see this one, after connecting to the U-tube, this is a U-tube, where the water is passing from this container and going into the U-tube. Now if you see this figure, you are having the pressure differences. You are having the height from here to here, it is a H1. The the manometric fluid is up to the datum line XX. Whenever this fluid is entering into this manometer tube, this manometric fluid is rising to the towards atmosphere, but it does not overflow. Okay, but it does not overflow. Then you can see how much height it is releasing. Then we are calling the mass H2. We are calling the mass H2, H1 and H2. Right now, by taking the consideration equilibrium, the pressures on the left limb of U2 is equal to the pressures in the right limb, left limb of the pressures to the right limb of the pressures. Then we are deriving P atmosphere. So the pressure inside the closed cavity at one point A, right? Pressure towards the atmosphere. Now it is given as PA plus gamma H1 is equals to gamma 2 H2 plus atmospheric pressure. That PA plus gamma W S1 H1, that is a specific weight S1 H1 is equals to gamma W H2 H2 plus atmosphere. That implies PA by gamma W is equals to H2 S2 minus H1 S1, which are in the meters of water. Therefore H is given by the height. This one, the height. The height is given by S2 H2 minus H1 S1. So if the hydrostatic pressure is considered, then the formula we can write H is equals to S2 H2 minus H1 S1. Just దీనికి 10.3 యాడ్ చేశారంటే then there is nothing but hydrostatic pressure. If H is a pressure head at a point A where pressure is required. Right. Now based on that, we will see one problem. Now the pipeline carrying the water has the connection of mercury. Now, so if you see the U2 manometer, so manometer is having a mercury as a fluid. Now the pipe carrying the water has a connection of mercury manometer connected to the container. The readings are measured as shown in the figure. Find the pressure of the water flowing in the pipeline. Now see the given data. So from the figure you have to take the data. So the question, in this question we don't have any data, but from the figure there is a general example problem. The solution, the values are given in the given data only. Now if H1, the height, what is this one? The height of water in the U2 in the left limb. The left limb anukunnamo. This one is a left limb. This one is a right limb. So in the left limb, what is the H1? The height of water up to the datum line in the left limb. That is equal to H1 is equals to 0.1 meter. H1 is equals to 0.1 meter. Next, whenever the water is flowing into the left limb, manometric fluid mercury అనేది ఆల్రెడీ ఇంతవరకు ఉంటుంది కాబట్టి ఇది పుష్ చేస్తున్నప్పుడు this manometer, this mercury is going up to which level? Up to some level. That H2 is equals to 0.8 meter. The specific weight of water is equals to 1. Specific weight of water SW is equals to 1. ఇవ్వకపోతే 1 అని తీసుకోవాలి. Value ఇస్తే then you have to consider the value. And at the same time, S mercury, specific weight of mercury is equal to 13.6 value. That is, you have to keep in the mind. Now, equating the pressure heads on both sides of the limb of the manometer, we have H of H1 plus H plus H1 specific weight of water is equals to H2 specific weight of mercury. So, here H plus ఎందుకు తీసుకున్నాడు? The overall general height. Therefore, that implies H is equals to H2 enter 0.8 into 13.6. ఇది ఇటు సైడ్ వెళ్తుంది కాబట్టి minus 0.1 into 1 is equals to 10.78. Therefore, H is equals to 10.78 meter. That is the answer for the given question. That is a head height. So, a formula you have to keep in mind for simple problems. H plus H1 S water is equals to H2 S mercury. Next. So, pressure in the pipeline will be, pressure in the pipeline will be PA is equals to PA is equals to rho water into GH. మామూలుగా pressure value వేస్తున్నాం. That is P is equals to what? That is rho into GH. The P is equals to rho into GH. P is equal to rho into GH. Starting class లో మనం derive చేసుకున్నాం కదా, pressure rho into G into H value. Now PA is equals to rho of water మనకి 1000 blind గా గుర్తుపెట్టుకోవాలి. G is equals to 9.81 గుర్తుపెట్టుకోవాలి. Height మనం already calculate చేసాం 10.78. Now the total value pressure in the pipeline. So find the pressure of water in the pipeline అన్నాడు కాబట్టి the pressure in the pipeline is 105.75 kilopascal. Now hydrostatic pressure apply చేస్తే దీనికి జస్ట్ ఏం యాడ్ చేయాలి? 10.13. ఇక్కడ చూసారా 10.13 అనేది యాడ్ చేయాలి. Now సో ఇదే ఫార్ములా తీసుకుంది ఇందాక అక్కడ. ఇది the pressure head కనుక్కోమని H is equals to S2 H2 minus H1 S1 H2 S2 minus H1 S1. See here. H is equals to S2 minus H1 S1 is equal to 10.78. Already వచ్చింది. Now how to find the hydrostatic pressure? Just add 10.3 H plus 10.3. Now PA is equals to rho of water into G H of 10 plus 3. ఈ H place ఉంది చూసారా, ఈ H place లో H plus 10 plus 3 యాడ్ చేయాలి. Now the same 1000 into 9.81 into 105.75 plus 10.3. So this is a actual thing. That is a hydrostatic pressure to be considered, right? This is the answer. Understood? Right. Now if you see the examples in that same process, how to find out the different problems based upon the different methodologies. Okay. Now see the first problem, example problem. The right limb of the simple U tube, the right limb ante the left, right there. The right limb of simple U tube manometer containing mercury is open to the atmosphere. So ikkada mercury undi. Black color is a mercury. This one is a right side. This one is a left side. So the U tube manometer is having the mercury to the facing towards the atmosphere, while the left limb is connected to the pipe. Which is water inside the container where you are having, in which a fluid of specific gravity 0.9 is flowing. So below ఎంత flow అవుతుంది? Specific gravity of 0.9, okay, is flowing. Next, the center okay, the center of the pipe is 12 centimeters below. The center of the pipe is 12 centimeters below the level of the mercury. In the right side, and one second. The center of the pipe is 12 centimeters below the level of the mercury in the right limb. Right. Find 12 below the mercury in the following. Okay. The center of the pipe is 12 centimeters below the level of the mercury in the right limb. Find the pressure of the fluid in the pipe if the difference of mercury level in the two limbs is 20 centimeters. So what is saying? Find the pressure of the fluid pressure pipe lo kanukomannadu. If the difference of the mercury level in the two limbs, left limb, right limb, is 20 centimeters. Right? Now see the figure. With this figure, you can say, so what are the levels you are having? In the left limb and the right limb? So in the left limb, you are having the water is facing at some x datum line. From here, the mercury is passing with a difference of 20 centimeters. Now, the pipeline, the center of the pipeline is 12 centimeters below the level of the mercury. Below the level of the mercury. Now, what is the given data? Specific weight of a fluid is equals to 0.9. In the question, you are having 0.9 value. So, the specific gravity of fluid S1 is equals to 0.9. The difference in the mercury level and the H2 is equals to 20 centimeters. The given, right? The difference in the mercury level in the ratio of the two limbs is 20 centimeters. The difference in the pressure head H2 is equals to 20 centimeters, that is 0.2 meters. Now, height of the fluid from X datum line, height of the fluid from X in the left limb. So, left in the left limb. Now, H1 kanukoవాలి. ఇది H2 కదా. This one is a H2. This one is H2. Now, this one is H1. So, what we have to do? You have to find the height. Now, H1 is equals to 20 minus 12. అంతే కదా. ఈ గ్యాప్ రావాలంటే ఇక్కడ నుంచి ఇక్కడికి రావాలంటే ఏం కనుక్కోవాలి? టోటల్ లో నుంచి ఈ బ్యాలెన్స్ తీసేస్తే ఈ బ్యాలెన్స్ అనేది తెలుస్తుంది. Now, H1 is equals to 20 minus 12, 8 centimeters, that is 0.08 meters. Now, what is the specific gravity of mercury? వాడు అక్కడ ఇవ్వలేదు, but we have to assume, we have to know that S2 is equals to 13.6. S2 is equals to 13.6. Now, let pressure at a point in this chamber, pressure at a point is, let PA is the pressure of fluid in the pipe. PA is the pressure of the fluid in the pipe. Now, we have PA by W is equals to P by W. Normal formula P by W kada. PA by W is equals to H2S2 minus H1S1. H2S2 minus H1S1 ఎక్కడి నుంచి వచ్చింది? ముందు మనం డిరైవ్ చేసాం కదా. See here, H2S2 minus H1S1. ఇక్కడ H తీసుకున్న height, right? Just we have H place లో we have written P by W. H place we have written P by W. Why? Because H is already known. Now, you have to find the pressure at a point. Pressure of a fluid at a point కాబట్టి pipe లో PA by W is equals to H2S2 minus H1S1. Now, substituting those values, H2 మనకి ఎంత? 20.2 meters. S2 is equals to 13.6 minus H1 is equals to వచ్చింది మనకి 0.08 meters and S1 is equals to 0.9. Therefore, substituting this one, W is equals to 9810 Newton per meter cube. Okay. Next. Now, PA by W is equals to 0.2 into 13.6 minus 0.08 into 0.9. That implies 2.648 meters. Now, PA is equals to, so ఇక్కడ ఏంటి? PA by W is equals to, ఇది వేసాం 0.2 into 13.6 minus 0.8 into 0.9. Same ఇదే ఫార్ములా. Sorry, we have applied the same thing. So మనకి PA by W is equal to H2S2 minus H1S1 చూస్తుంది కదా. Where W మనకి, if it is not given the weight, you have to assume 9810 Newton per meter cube. Now, ఈ value substitute చేస్తే, right, PA by W is equals to same 0.2 into 13.6 minus 0.08 into 0.9, that is equals to 2.648. Now, PA is equals to 2.648 into W మనకి 9810 ఇచ్చారు. That ఇది ఇంప్లై చేశారు అంటే the final value is equals to 25.97 pascals. That is the answer for the question PA. Okay na? Next. So, why the students are very low? The students are very less. Please join the class. Next, this is the second question. A simple YouTube manometer, Riyadh Sheikh, వినిపిస్తుందా? Riyadh, are you there? Riyadh. Hello, Riyadh. Just open your mic. Shravani. Okay. Take the second one.
Sir.
Morning classes జరిగాయా? Morning classes జరిగాయా?
Sir.
Morning classes
బ్రేక్ అవుతుంది సార్.
Morning classes జరిగిందా? Classes జరిగాయా morning? Hello. Is audible? Morning classes జరిగాయా? Hello. మరి ఏంటి ఈరోజు ఓన్లీ టూ మెంబర్స్ ఉన్నారు? Only 2 students are present in this class, Shravani and Sheikh, Riyadh Sheikh. What about others?
Sir.
Remaining వాళ్ళు ఎంతమంది వచ్చారు మార్నింగ్? తక్కువ ఉంది
సార్. వాయిస్ బ్రేక్ అవుతుంది.
వినవడం లేదా వాయిస్? హలో, is it audible? Hello.
Okay sir.
స్టూడెంట్స్ తక్కువ మంది ఉన్నారు, ఇద్దరే ఉన్నారు. మార్నింగ్ ఎంత మంది వచ్చారు?
నో సార్.
మార్నింగ్ 6 మెంబర్స్ వచ్చారు సార్.
మరి ఇప్పుడు ఇంకా ఇద్దరే ఉన్నారే. లంచ్ చేసి నిద్రపోయారా అండి? లంచ్ అయినాక నిద్రపోతున్నారా? లంచ్ అయిపోయి నెక్స్ట్ క్లాస్ ఉందా మీకు? నెక్స్ట్ 3:15 క్లాస్ ఉందా లేదా? మో ఇన్ఫర్మేషన్.
నేనైతే లేదు సార్. ఇవాళ ఉందో లేదో తెలియదు సార్.
నిన్న లేదు క్లాస్. ఓకే.
నిన్న లేదు సార్.
ఓకే. నేను స్టూడెంట్స్ ఇన్వైట్ చేశాను గ్రూప్ లో. జస్ట్ నౌ అగైన్ ఐ సెడ్ జాయిన్ ద క్లాస్. Join the class. What's up? Okay. So okay, we will continue. See the next problem. So a simple YouTube manometer containing the mercury. Here also you are using the mercury. Mercury ఇచ్చినప్పుడు simply S is equals to 13.6 అని మీరు గుర్తుపెట్టుకోవాలి. Now, simply containing manometer containing the mercury is connected to a pipe in which a fluid of specific gravity is 0.8. So here S1 is given. S1 is 0.8. S1 is 0.8. Until left side తీసుకోవాలి first మనం. This one is a left hand side. This one is a right hand side. ఇది left hand limb అంటాము. This is a right hand limb. Left లో ఏముంది మనకి? ఇది is a fluid. It may be water or kerosene or any other oil. బట్ మానోమీటర్ లో మనకి మెటీరియల్ ఏదైతే ఉందో దాన్ని మనము 2 కింద సెకండ్ ఫ్లూయిడ్ కింద కన్సిడర్ చేసుకోవాలి. లెఫ్ట్ సైడ్ ఫస్ట్ ఫ్లూయిడ్ కింద కన్సిడర్ చేసుకోవాలి. సెకండ్ సైడ్ సెకండ్ ఫ్లూయిడ్ కింద కన్సిడర్ చేయాలి రైట్ సైడ్. రైట్ నౌ ద స్పెసిఫిక్ గ్రావిటీ is 0.8 అండ్ హ్యావింగ్ వాక్యూమ్ ప్రెషర్ ఈస్ ఫ్లోయింగ్. సో దీని లోపల ప్రెషర్ ఎలా ఉంది? హియర్ వాక్యూమ్ ప్రెషర్ ఈస్ ఫ్లోయింగ్. నెక్స్ట్ ద అదర్ ఎండ్ ఆఫ్ ద మానోమీటర్ ఈస్ ఓపెన్ టు ద అట్మాస్ఫియర్. సో వాక్యూమ్ అంటే క్లోజ్డ్ అనమాట. So here the container is totally closed. Here the YouTube manometer is open to the atmosphere. అంటే మనకి P atmosphere అనేది కంచి వస్తుంది. Open to the atmosphere. Now find the vacuum pressure in the pipe if the difference. Find the vacuum pressure in the pipe if find the vacuum pressure in the pipe if the difference of the mercury level in the two limbs is 40 centimeters. So the difference is 40 centimeters and the height of the fluid in the left from the center of the pipe is 15 centimeters. So this is a center and center of the pipe ante enti idi total height anukunte. So this is a upper height, this is a lower height, this one is a center of the pipe. Now write the given data what is there in the question. Now the specific gravity of a fluid S1, the specific gravity of fluid S1 is equals to 0.8. ఏది దీంట్లో ఉంది 0.8. Here it is in the 0.8. Here. Next, the specific weight of the mercury S2 is equals to 13.6. Next, height of the fluid in the left limb. Height of the fluid in the left limb is 15 centimeters. Height of the fluid in the left limb. Then height in the limb lo కనిపిస్తుంది కదా fluid వేరే dash గా. This one is the height of the fluid in the left limb. H1 is equals to 15 centimeters. Convert into meters. Difference in the mercury level. The difference in the mercury level is 40. H2 is equals to 40. That is equal to 0.4 meters. Right. Next, let PA is a pressure. Let PA is a pressure in the container, in the pipe. Let PA is a vacuum pressure present inside the pipe. By this is a given data. Now what to find? Therefore, ఇక్కడ మనకి vacuum pressure అంటే negative pressure కదా. So here the pressure is in the vacuum pressure అంటే negative pressure. Negative pressure means we have to apply minus. We have to apply minus notation. Now PA by W is equal to minus of H2S2 minus H2S2 plus H1S1, where W is equal to specific weight, that is equal to 9810 of the water. Therefore W is equals to 9810. Now PA by W is equals to, substituting the same values what you are getting in this. So ఈ values ఏవైతే ఉన్నాయో just substitute as it is in this process. So W9810 అని ప్రతిసారి మీరు అజ్యూమ్ చేసి ప్రతిసారి మీరు మైండ్లో గుర్తుపెట్టుకోవాలి. Now PA by W is equals to minus of 0.4 into 13.6 plus 0.15 into 0.8. That is equals to minus 5.56 meters. Now ఈ W ని దీంతో మనం మల్టిప్లై చేస్తే PA value is equals to minus 545. Therefore PA is equals to minus 54543.6 kilopascals. And then 1000 వేసుకుంటే we are getting 54. లేదంటే ఇంతకైనా we can keep and leave it. That is the answer in the given problem. ఇక్కడ ఏమన్నాడు, find the vacuum pressure అన్నాడు. vacuum pressure అంటే ఏంటి? PA కనుక్కోవాలి. vacuum pressure is PA. vacuum pressure is the PA. Understood the problem? Right. Okay. See the next one. The left limb of the U-tube mercury. The left limb of the U-tube mercury manometer is connected to a pipe. The left limb of the U-tube mercury manometer is connected to, ఇక్కడ ఏం చేసుకోండి, the mercury లో U-tube లో it is a mercury is connected to the pipeline conveying water. So ఇప్పుడు దీనిలో అదర్ దాంట్లో ఏముంది, you are having a water. The level of the mercury in the limb being 0.6 meters below the center of the pipeline. Center of the pipeline అన్నప్పుడు సింపుల్ గా దీన్ని కన్స్ట్రక్ట్ చేసుకోవాలి. ఎందుకంటే why it is center, ఇది ఆల్రెడీ హైట్ ఉంది, రైట్, ఇది ఆల్రెడీ దిస్ హైట్. సో ఇక్కడ నుంచి ఇది సెంటర్ తీసుకున్నప్పుడు దీని కింద నుంచి ఎంత అయితే ఉందో అది ద బాటమ్ లెవెల్, ద సెంటర్ లెవెల్, దిస్ ద టాప్ లెవెల్. ఓకేనా? Now the level of the mercury in the limb being 0.6 meters below the center of the pipeline and the right limb is open to the atmosphere. The level of the mercury in right limb, the height is chewed. The level of the limb in the H2 limb height is equals to 0.5 meters. Above that, in the left limb and the space above the mercury in the right limb contains benzene solution. Specific gravity is equal to 0.8 to the height of the sorry, we are having some technical problem. Okay, we'll continue here. So here in this problem, so what is the given here? The given data is given at the given dimensions. Now write the given data as per in the question. What is the given data? the height of the water is given. The height of the water is given. H1 is equals to 0.6 meters. See, where is the height of the water? The height of the water, the level of the mercury in the limb being 0.6 meters below the center of the pipeline. Next, the height of the mercury H2 is equals to the level of the mercury in the right limb is equal to 0.5. Next, 0.5. Next, what is the 0.3 here? Benzene height. Benzene specific height to the height is 0.3. H3 is equals to. So now totally you are having 3 liquids in the container as well as your U2 manometer. So height of water is 0.6. Height of mercury is 0.45. Height of the benzene is 0.3 meters. Now, specific rate of having a technical problem. Internet is very slow. So be patient. Be patient. Okay. Okay. Now see the specific weight of water is S1. Already you have to keep in mind specific weight of water is S1 is equal to 1. But it is not mentioned in the question. Now the specific weight of mercury is 13.6. Next, the specific weight of benzene is given as H3 is equal to 0.8. Now see the figure. We know that the pressure in the left limb and the right limb above the datum line are equal. Thus computing. Now see here. So here in this liquid, in this pressure container, so which is closed, where you are having a water up to this level. So this figures, if at all the question you are getting in any exam question is that definitely you are having the figure. Don't worry. Figure to goda untundi problem. By seeing the figure you can do the process. Now up to this level, up to the datum line XX, so in this glass pipe water is filled. Okay na? The water height is equals to 0.6. Next, after this datum line XX, the mercury is flowing to certain level. The mercury is flowing to certain level to certain height. So what is the height of the mercury H2? The height of the mercury H2 is equals to 0.45 meter. Next, 0.45 meters. The height of the benzene liquid. So the height of the benzene liquid is showing in the other design. It is not a spring, just only the design changes. Here the benzene height is 0.3 meters. So H1, H2, H3 మూడు వచ్చేసింది అన్నమాట. Then the specific కూడా మనము తీసుకున్నాం. Now applying the same formula, PA by W plus S1 H1. S1 H1 ఏంటి వాటర్ కాబట్టి వాటర్ ఇటు తీసుకున్నాము. S2 H2 plus S3 HT. ఇక్కడ మనకి నెగటివ్ ఏం లేదు. Why? Because the question law is not mentioned as a vacuum pressure. Okay now. Next. Now substituting the values PA by W plus S1 H1 and the S1 is equals to 1 into H1 is equal to 0.6. Therefore 1 into 0.6 is 0.6. Next, S2 value enta 13.6. H2 value enta 0.45 into 45 plus S3 value question lo ichchadu 0.88 into H3. H3 is equals to 0.3. Therefore by calculating all this one, you are getting 5.784 meters of water. That is, it is approximately 5.8 meter. Approximately 5.8 meter. Now, the pressure in the pipe PA is equals to 5.784 into W. Already we know that W is 9810. Then 9810. The answer is 56,741 Newton per meter square. That converting into pascals, 56 by 1000 చేసుకుంటే 56.741 kilopascals. That's the answer for this question. So ఇక్కడ ఏమి ఇచ్చాడు సింపుల్ గా, it is given 3 liquids, but don't get confused. The concept and the formula is same. Whatever you are getting. So for a given data, if you write a given data, you will get 2 marks. If you write the formula, you will get 2 marks. And if your calculation or somewhere something is wrong, at least there will be 2 marks, or totally there will be the 2 marks if the problem is correct. Right? Next. So in this unit, you are having 40% theory and 60% problems. So మీరు పేషెన్స్ గా వినండి, అర్థం చేసుకోండి. ఈ టాపిక్ అయిన తర్వాత ఇంకొక హైడ్రోస్టాటిక్స్ అని ఉంటుంది. అందులో కూడా you are having majority derivations and problems. Don't get tensed, don't get disappointed. Okay na? Right. A U-tube manometer containing a mercury has its right limb open to the atmosphere. Okay, telusinde. The left limb is full of water under pressure, the center of which is in level with the free surface of the mercury. Find the pressure of the water in the pipe above the atmosphere. If the difference of level of mercury in the limbs is 5.08, H2 ఇచ్చాడు 5.08 అని. ఓకేనా? Now the height of the water in the left limb is equals to height of the mercury in the right limb. So what we said here, the left limb are full of water under pressure, the center of which is level in the free surface of the mercury. Find the pressure of water in the pipeline above the atmosphere if the difference is 5.08. Okay, now H1 is equal to H2. So it is given as left limb low, right limb low, the height is same, right? The height is same. Next, H2 is equals to 5.08 centimeter, that is equal to 0.508 meters. Next, so rendu equal ga undi. The left limb is full of water under pressure annadu, the center in the level is free surface of the mercury. Okay na? Next, ఇక్కడ ఏం చెప్పాడు ఇక్కడ, in the pipe above atmosphere, if the difference of the mercury in the limbs, in the total limbs అంటే 2 కాబట్టి left limb right limb. So here left limb is equals to right limb. H1 is equal to H2. Therefore H1 H2 is equals to 0.508 meters. Now see here. So here రెండు ఈక్వల్ గా ఉన్నారన్నాయి కాబట్టి మనము H1 H2 అనేది సేమ్ తీసుకున్నాము. ఓకేనా? నెక్స్ట్, the specific gravity of mercury, you know that mercury specific gravity is 13.6. The specific gravity of water S1 is equals to 1. ఇక్కడ S1 13.6 తీసుకోవచ్చు కదా అని మీకు క్వశ్చన్ డౌట్ వస్తే, సో జనరల్లీ లెఫ్ట్ హ్యాండ్ సైడ్ ఫస్ట్ తీసుకోవాలి. లెఫ్ట్ హ్యాండ్ సైడ్ ఏముంది? వాటర్ ఉంది. సో వాటర్ S1 స్పెసిఫిక్ వెయిట్ ఎంత? 1. రైట్ హ్యాండ్ సైడ్ ఏం తీసుకోవాలి? సెకండ్, any liquid, it may be a mercury or it may be any kerosene or it may be any some other oil, you can take it as 2, but don't get confused. S1 ante water తీసుకోవాలి, S2 ante mercury గాని అదర్ మెటీరియల్ తీసుకోవాలి. He said the pressure difference in the limbs is 0.8, that is equal to H1 is equal to H2. Now applying the formula, PA కనుక్కోమన్నాడు. PA you have to find out. Now PA by W is equals to H2 minus H1 S1, S2 H2 minus S1 H1. According to the formula, PA by W is equals to S2 H2 value ఎంత? 0.5. సో ఇప్పుడు రెండు H1 H2 కామన్ కాబట్టి ఇక్కడ ఏం చేశారు? H1 S2 వాల్యూ సేమ్ కాబట్టి దీన్ని కామన్ బయటికి తీసి రైట్ S2 మైనస్ S1 పెట్టాడు. S2 ఎంత? 13.6 మైనస్ 1. therefore దీన్ని మనము క్యాలిక్యులేట్ చేస్తే 0.640008 meters of water అనేది మనకి తెలుస్తుంది. Now PA is equals to EW తీసుకొని ఇక్కడ ఇన్సర్ట్ చేస్తే 9810, that is equals to 6.279 kilopascal. So that is the pressure available in the container whenever the heights are equal in the left hand side and the right hand side. So ఈ సింగిల్ యూట్యూబ్ మానోమీటర్ ప్రాబ్లమ్స్ వస్తే ఇది లెఫ్ట్, ఇది వచ్చేసి రైట్. ఓకేనా? whenever in the question if there is a given specific weights also, first consider left hand side ఏముంది? S1 ఉంటుంది, right hand side ఏముంటుంది? S2 ఉంటుంది. So mention and clearly write the notation. So like this you are doing the problems in the YouTube manometer. Understood? Next, single column or micromanometer. So here the single column or micromanometers are just similar to the YouTube manometer. Only the difference ఏంటి? మనకి ఇక్కడ ఒక small reservoir అనేది ఇక్కడ పెట్టున్నారు. Reservoir in the tube as shown in the figure 2.9 and 2.2. Micromanometer has a glass tube bent in the U shape సో మనకి ఆర్మర్ ఇందాక మనం చూసినట్టు ఇక్కడ కూడా bent in the U shape or inclined and has a small reservoir in the tube. ఒక small reservoir అనేది ఒక చోట ఉంటుంది. Having some amount of same or different fluid called manometric fluid. సో దీనిలో లిక్విడ్ ఉందనుకోండి, వాటర్, దీనిలో వాటర్ అయినా ఉండొచ్చు, కలర్ వాటర్ అయినా ఉండొచ్చు. దీనిలో లిక్విడ్ వాటర్ ఉందనుకోండి, దీనిలో కిరోసిన్ అయినా ఉండొచ్చు, లేదంటే ఎనీ హైడ్రాలిక్ ఆయిల్ అయినా ఉండొచ్చు, లేదంటే జనరల్ గా మనం మాట్లాడుకున్నట్టు మెర్క్యూరీ అయినా ఉండొచ్చు. నౌ see the figure here. Just before connecting a micrometer connect చేసినప్పుడు after connecting the micrometer setup ఎలా ఉంది. See, so this is a closed container where you are having fluid 1 in the pipe. So this is a pressure point at A. This is connected to the micro manometer, single column manometer, where the other end is connected to the atmosphere. So whenever the manometric fluid is filled and it is grown, because of the pressure difference lying here, changes in the datum line, right? The manometric fluid is rising to atmosphere to some level. Then this one is H2, this one is H1. So in this way you have to do the process in this micro manometer. Now the change in the datum line is delta H is equal to delta H. So from this one, so if this is the area, atmospheric area outside, but this is the area what you are having the balance. Now if any pressure point at A in the fluid, capital A, is greater than A. So if small a is less than the greater A, then small a by A is equals to 0. Then with this we'll give H is equals to inda మనం చెప్పుకున్న ఫార్ములా H2S2 is equals to H2S2 minus H1S1. If the tube is inclined, so if the tube ఇలా ఉందనుకోండి, సో ముందు ఫిగర్ ఎలా ఉంది, the tube అనేది straight గా towards facing upwards, but here what it is, here the tube అనేది so U shape లో లేదు. Here the tube is not in U shape, it is directly showing like this. It is directly showing in this direction. Okay na? Next. Now the tube is inclined to the reservoir at an angle theta. So here the angle is given as a, so ఇక్కడ మనకి angle ఏం లేదు ఇక్కడ, straight parallel to the ground. But here whenever you are making an angle, automatically theta అనేది exist అవుతుంది. Okay, next. Then we can write H2 is equals to L of sin alpha and so on, L of sin alpha. Therefore H is equals to, total H is equals to small a by capital A, area of the fluid in the glass tube. H is equals to small a by A to the bracket L sin alpha S2 minus S1 to the bracket plus L sin alpha S2 minus H1 S1. So this is the formula for the true inclined at an angle. So, and if A is equal to 0,